Okay, number 7, Ethan, your favorite type. So find the volume of the solid formed when the region bounded by y equals 3 to the x, y equals 3x, and the y-axis from x equals 0 to x equals 1 is revolved about the x-axis. Well, first thing I'm going to do is I'm going to sketch a picture. Pretty much talking about quadrant 1 here. Y equals 3 to the x, then that's an exponential, right? Whether it's y equals 2 to the x, 3 to the x, 4 to the x, whatever, it's an exponential. And those functions are the ones that run along the x-axis over here. What did I do? That was weird. Okay, let me try drawing that again. They run along the x-axis. They usually cross up through 1, and they go up like that, right? I feel like that probably should have gone up a little quicker, but we're just going to make it happen. And then y equals 3x. Yeah, I didn't do that curve very well. Y equals 3x is a line. Goes through 0, 0, has a slope of 3. And yeah, my drawing's not going to be very accurate because what's going to be happening, gosh, I can't even. This is going to drive me crazy, guys. Nope, I can't. I gotta redraw that curve so that I can make this happen. Well, I don't know if that's the greatest either, but it's better than it was. I can deal with it a little bit better, which is what I just need to be able to get through this. I just have to be able to deal with looking at my own drawing here. So, okay, we have those two pieces. So it's those two pieces, the y-axis, which is that piece, that short little piece between the functions, and then from x equals 0 to x equals 1. That's the thing. I was thinking 1 was an intersection point, but they tell us 1, don't they? Okay, so from x equals 0 to 1, and so it's that little thing inside there. I don't know where they intersect actually then after all. That's fine. I don't have to know. And revolving about the x-axis. Now, because we are revolving around the x-axis, there's a gap here, isn't there? There's a gap there. Because there's a gap between the bottom function and the x-axis, that's what tells me that this is a washer method. Okay? So we do need to think washer method. When we do washer method, so disk method is pi times radius squared. So pi times function squared, right? For washer method, we're doing pi times big R squared minus little r squared. That's the gist of it, right? So I know I need pi. The integral. What are my boundaries? 0 and 1 because we're revolving around the x-axis and they told me 0 and 1. Otherwise, we need to find the x value of that intersection point. But gotta love when they're nice to us. Okay? Now, big R squared minus little r squared. What do I mean here? Big R squared.
Out minus in, right?
Okay. The farthest one away from where you're rotating minus the closest one you're rotating. So since we're rotating here about the x-axis, the farther away equation is that top piece, which is 3 to the x. So we're going to say 3 to the x quantity squared. Okay? Minus little r is the one closer to your axis of rotation, which is 3x. So this time 3x quantity squared. Times dx, this is all, I'm working in terms of x's because I'm rotating about the x-axis. My boundaries are values on x values because I'm working around the x-axis. Okay, I'm going to do a cleanup before I integrate here. Pi times the integral from 0 to 1. What is 3 to the power of x squared? What happens when you raise a power to a power?
3 to the 2x.
When you raise a power to a power, you end up multiplying your powers. And x times 2 is 2x, so 3 to the 2x. Minus, what is 3x quantity squared? 9x squared, because you're squaring the whole amount. So 3x times 3x, 9x squared. Bless you, yeah. The timing was weird just because with the bell starting to ring, it sounded weird to me, but. Okay, I'm keeping my pi outside. Integral of 3 to the 2x. Oh.
I was going to say we have something for that, right?
Well, we do, but that 2x makes it a little challenging here. I just looked at the answer key and realized what we should be doing on that 3 to the 2x. Because 3 to the 2x, it's those pieces, the 2 and x are multiplied. It's 3 to the second and 3 to the x.
So can you split it?
I'm not going to split it. I'm going to simplify it another step, which I overlooked. 3 squared. So 9 to the x. And that's probably the better way to write it, because we know how to integrate that easier. Sorry, I would have done that last time had I processed it. But because 3 to the 2x is 3 to the second and 3 to the x, so it would make sense to have the 9 there. Okay, so now I've got my pi, and yes, we have something for integrating an exponential like 9 to the x. And it's easier to do with 9 to the x than 3 to the 2x. Remember using natural logs in there and fractions.
Isn't it like 1 over x ln a, or 1 over a ln x? But that might be the derivative.
That might be the derivative. I know I'm trying to process in my head too, because that's not. The integral of 9 to the x is 9 to the x divided by natural log of 9, right? Yeah.
So it's a to the x over ln a.
I think so. I'm double checking myself here, because I'm all of a sudden. What lesson do we go back to for that?
I have no clue. I'll get simple to know how.
And then my brain's not there on that one today. Was it this far back?
I feel like that was at least before.
Oh, was it? Okay, well. Here we go. Yeah. Okay, integrals of a to the x. A to the x over ln a. Yeah, 73 for a reference lesson. Which means the derivatives were 72. Yep. Okay, sorry guys. I got hung up. 9x squared. Add 1 to the power, divide by a new power, and yeah, I say 3x cubed. Evaluated from 0 to 1.
In this case, the 0 just makes it 0. Or no, it doesn't.
Yeah, don't. This is one of those, do not just, oh, I don't need the 0, I'm good, because you will miss. So if we put in 1, it's going to be 9 over natural log of 9 minus 3 times 1 to the third, so minus 3, minus, we put in 0. 9 to 0 is going to be 1 over ln 9, and then minus 0. So there is a 0 in there, but you do have to consider this. I probably cleaned it up on the answer key some, I would think. In that, so there's a pi out front. We have a 9 over natural log of 9 minus 1 over natural log of 9. Well, 9 over natural log of 9 minus 1 over natural log of 9 is 8 over natural log of 9. Common denominator, right? And then we still have a minus 3. It is volume, so I should say units cubed, but I didn't do that. I did on the answer key. I just didn't. Here. I'll slide it in right here. Okay?
Mackenzie Gibson to the high school office. Mackenzie Gibson to the high school office.
Okay. Sorry. Is that my Monday rough issues there coming through? Oof.
Heck, if you're going through it, imagine what we're doing right now.
Just goes to show there, pieces that if you don't use them on a regular basis, I forget them at times too. Okay, next.
I could go for number 1 again.
Yeah, I'm not getting.
Yeah, me either.
Okay. Numero uno.
C.
A particle moves along the x-axis, so its position at any time is given by the function x of t equals 7t minus 2t squared. Find the total distance traveled by the particle between t equal 1 to t equal 2.
Okay, so it's the one where you plug in 1, plug in 2, and then add those two equations, or add those two answers together.
You have to find any zeros or if I change it.
Right. We have to look at, because the total distance traveled, this is a position function. We don't know what happens between 1 and 2. If it just from time 1 to time 2 is traveling in one direction, then yes, you can just plug in 1, plug in 2, and look at those values. However, what if it stopped and turned around during that time? Okay, so, and they're asking for total distance traveled, which there would be overlap then. So, in order to figure out any place it might have stopped, we need to look at zeros of velocity. We need critical points, right? And critical points are zeros of the derivative. The derivative in this case is velocity. So we're going to do x prime of t, if you will. You could also call it v of t. Derivative here is, I wrote 7 minus 4t, but I'll agree with you. We're going to set this equal to 0. Bless you. So there is a critical value at 7/4. Is 7/4 on the interval from 1 to 2?
Yes.
It is. So at this point, we need to figure out the position at 1, the position at 7/4, and the position at 2. And so when I'm saying find the position, we're taking those critical values And we don't want to put them back into velocity. We've got to put them back into the position function, right? So when I put x of 1 in, 7 minus 2 is 5. When I put 7/4 in, my brain says, ugh.
Yeah, exactly.
And again, we could do that by hand. It's not impossible by any means. However, and my brain is saying 7/4 is 1 3/4 or 1.75. So 7 times 1.75 minus 2 times 1.75 squared. 6.125, so 6 1/8. Then if I put in 2, 14 minus 8 is 6. See, I can do 2 and 1 in my head. Piece of cake. You've seen my brain is on the rough edge today, so calculator can help me. So what do we know? From time 1 to time 1 3/4, what did this particle do? It traveled 1.125 units, correct? Then, from time 1 3/4 to time 2, how far did my particle travel? 0.125, right? And technically, I know we're going to say, okay, that's a negative direction, but it's still that distance, okay? Whether you're driving your car in forwards or driving your car in reverse, it's still a distance.
Yeah, I remember that because I remember distance is a scalar, velocity is a vector, which means velocity has a sign on it, but distance doesn't. We learned that in basic physics.
Car analogy just doesn't go all the way. It just, But, okay, so together we are adding these because these are distances, right? These are units traveled, and so we add these for a total of 1.25.
Yeah, I had all the numbers. It's just I think first I was trying to think about it, how far it moved rather than distance traveled. And I was instead of starting at 5, I started at 0.
Yeah.
So I'm trying to get 0 to 5 to that backside.
Yeah, but we don't need the 0 here, yeah.
In the event that 4 looks attractive to anyone else, we can do that.
I was just starting off.
Well, there's a couple of identities you have to remember here, so we can definitely look at 4. Yes?
Do you mind if we go over 6?
6 would probably be good to look at, too. They're all good to look at, what am I saying? But, Okay. Let me do 4 real quick. I think that'll be somewhat quick in terms of what we're doing here. I will say, notice it says exact. So do I want a calculator value? So the integral from negative pi to pi of sine squared of 2x dx. Now, how do we integrate powers of sine when they're even powers? And we have
Like 1/2 minus cosine, or 1/2 minus cosine.
oops. I have these identities written on the answer key. And I have both identities written on the answer key, right? Which means, reminder, you need to be familiar with both. Don't ever just learn one because, opposite is often on the test, but on the flip side, it could be that, you never know. So we learn them in pairs anyway. So when we are integrating these even powers here, we're going to sub it out. So integral from negative pi to pi, sine squared, well, I'm going to do 1/2 minus 1/2 of cosine 2x.
So it's 2, not 1, so it's multiplied by 2.
Right. So if you look right here, the rule is for sine squared of x. And so this says to do 2 times whatever is in the sine squared. Since ours is 2x, we're doing 2 times 2x, or in other words, 4x. Did you catch that? Okay. So yes, I am integrating from negative pi to pi of 1/2 minus 1/2 cosine 4x dx. Okay, get the easy one out of the way. The integral of 1/2 is 1/2 x, right? Minus, and I'm going to do this next one in pieces. There's the 1/2 that's already there, yes? What is the integral of cosine? Integral of cosine is sine, so the integral of cosine 4x is sine of 4x. But
1/4, right?
right, so if you're doing the derivative of sine of 4x, you'd have to say times the derivative of 4x, which is 4. How do I compensate for that 4? We say 1/4. And then this is all evaluated from negative pi to pi. Okay? So, and this is one of those things, if we knew what the graph looked like, maybe it's symmetric and we can do 2 times 0 to pi. But that only works if we know what the graph looks like, right? So if I plug in 1/2 times pi, I'm going to call that pi over 2, minus 1/8 sine of 4 pi, minus, then the quantity. Now I'm plugging in negative pi. So it's 1/2 x, so negative pi over 2, minus 1/8 of sine of negative 4 pi. Well, what do you know about sine of 4 pi?
Be the same thing as the sine of 0, right?
Right, yeah. Because if you count in multiples, you start at 0, you go once around the unit circle, you're at 2 pi, you go around again, you're at 4 pi. So 0, 2 pi, 4 pi, 6 pi, 8 pi. Those are all the same. So sines of 4 pi is going to be 0. What about sine of negative 4 pi? It's the same thing, right? All those even pi's are going to be 0. So we really have pi over 2 minus negative pi over 2. What's 1/2 pi minus negative 1/2 pi? And that is pi. Okay? Appears easy, but on the flip side, there's some things to remember, and there aren't there.
Just keep remembering how to do stuff.
Yeah.
Keeps coming back.
It does keep coming back, doesn't it? Okay. Abby, you said 6?
Yeah.
The mean value theorem of integrals states that every continuous function on a specified interval attains its average value at a point C on the interval. Let f of x be the given. Find the value of C on the interval 1 to 5, guaranteed by the mean value theorem of integrals. Okay. I gotta remember what lesson number this is?
So, isn't it like f prime of C is equal to f of B minus f of A whole
think you had it. I wasn't fully, I was flipping, so I wasn't fully listening. So less than 89 is where you find mean value theorem for integrals. If f is continuous on the interval, there exists at least one number c between a and b such that, and the reading is, for the reference sake here, this is straight out of the notes, f of c is, 1 over b minus a times the integral from a to b of f of x dx, right? So that is the whole mean value, that's what we need to be remembering there. I notice it does throw in the word average value. And we talk average value, that 1 over b minus a is what I've mentioned before, right? When you hear them asking you to do an average thing, I can't say always, but often, they want that 1 over b minus a. So, let's go ahead and see. I guess I should have written down. I don't really want to write it right there. Okay. Our given f of x here was 3x squared minus 12x plus 10. Okay, so f of c, 1 over b minus a, which the given integral was, or given interval, interval. Given interval is 1 to 5, so that's going to be 5 minus 1 because those are your a and b values. So 1 over 5 minus 1 times the integral from 1 to 5 of f of x, which f of x in this case is our 3x squared minus 12x plus 10 dx. Okay? Clean up, right? Keep in mind this is f of c we're finding, so 1 over 4 times the integral. So let's see, let's integrate. Integral of 3x squared, x cubed, minus 6x squared, plus 10x, evaluated from 1 to 5. Stop me if I get going too fast, but the basics I think you're fine with here. Go ahead and evaluate. I'm going to keep my 1/4 out front. I'm going to plug in 5. 5 to the third, I believe, is 125. Minus 6 times 5 squared. So 6 times 25, 150. Plus 50. Minus, now I'm going to put in 1. 1 minus 6 plus 10. In all honesty, the math by itself isn't too bad here, because this piece is 25. Minus 5, so 20. So we're doing 1/4 of 20, and 1/4 of 20 is 5. Okay, so based on the mean value theorem for integrals, based on that formula, we get f of c is 5. Now, how else can I find f of c? Well, we can use this right here, yes? We can find f of c here, plugging c in, to be 3x squared minus 12x. Really? Anyone catching what silly business I'm doing here? I just said let's find f of c, and I'm still using x.
It's one of those days.
I have zero excuses. It just, okay, so f of c, at this point, if I'm using f of x, I mean, one way I found f of c was using the given formula. The other way to find f of c is to plug c in. So f of c is going to be 3c squared minus 12c plus 10. Well, we have two f of c's, right? F of C is that. F of C is that. So if F of C is equal to both of those items, then they're equal to each other. So 3C squared minus 12C minus 10 is equal to 5. It's a quadratic, yes?
I would say, do I spell quadratic?
Yeah, I don't have it factory. So make it equal to 0, right? 3C squared minus 12C minus 5 equals 0.
So it wouldn't be a plus 10 like it was on the f of x, or would it? Okay. I was confused for a minute.
Although it still ends up being no, it does. It becomes plus 5 now, doesn't it? Okay, thank you for catching that before I went too much farther. Again, I don't know. I'm just having a day, okay?
It's okay.
This is your job at this point. You've learned everything, right? So it's your job to catch all my crazy mistakes that I'm making today. Got it? Okay. Now, what I was getting ready to do is, you can check product of AC and just make sure, but you'd have to have something that multiplies to be 15 and adds to be negative 12. So, yeah. Quadratic formula. Since I'm solving for C, it's going to be C equals negative B, 12, plus or minus the square root of negative B squared, B squared, 144 minus 4 times A times C all over 2A. 12 plus or minus 144 minus 60, 84 over 6 square. So 12 plus or minus the square root of 84 over 6. Now, technically, square root of 84 has a perfect square in there. Okay? Because technically, 84 divides by 4. So square root of 84 is square root of 4 times 21, which is 2 square root of 21. So if this is, I'm going to run out of room, 12 plus or minus 2 square root of 21 over 6, that's where I did a little bit more reducing, because 12, 2, and 6 all divide by 2. So if I divide those all by 2, I have 6 plus or minus the square root of 21, all divided by 3. I'm going to circle that because it's getting lost in everything else. Now, I don't exactly know that value, but are we on a certain interval here? We are on a certain interval, weren't we? We were given 1 to 5. So this is where I would double check. 6 plus the square root of 21 divided by 3 is 3.527, yada, yada, yada. 6 minus the square root of 21 divided by 3 is 0.47. My interval is 1 to 5. So do both answers work? No. The answer that works was the plus. Yeah. So, final answer, 6 plus square root of 21 over 3, because that's the one that's in the interval. Okay? So, even if you would have left it, because I know some of you don't always simplify, if you would have left it as 12 plus or minus the square root of 84 over 6, it's still the same issue. You can't leave it as plus or minus. You have to give the plus only. Does that make sense? Okay. And that's because that's the only plus is in the interval 1 to 5. Sorry, my screen got really messy here. Although, in my opinion, it's only really messy if you look back at it at the end. Going through it,
Like if I just like pulled this up and I was like, I would be like, oh.
but from the beginning it was fine. I started on the left, then I went to the right, but I kind of started running out of room. So, okay, you are giving me all the signals that we are about out of time. It's the truth. I mean, you know.
What's going on?
Okay,
Hot dog, five.
hit me up for questions. Before school, after school, homeroom, whatever you guys need. Ethan, I hope you've enjoyed your few problems here.